friends, so it's Coach Fred here, and today I'm going to be going over a few more problems from the Trig test. I'm on number 11. It says find all 6 trig functions. So that's sine, cosine, tangent, secant, cosecant, cotangent. Okay, so several ways to approach this, but we got to make sure we understand it. It says if sine theta equals negative 7 over 25, so that's the sine's ratio, and it's negative, so I got to pay attention, and that theta, is between pi and 3 pi over 2. So I have to think about where that is. So first of all, pi is here, and 3 pi over 2 is here. So theta is between them, okay? That's that, compound inequality showing me where it is. So I'm in quadrant 3. Okay, so that means I'm going to draw an angle, a theta, in quadrant 3. So I'm going to draw a triangle in quadrant 3. Now remember, the reference angle, or theta, will always be the acute angle formed with the x-axis. Okay, so this is one way to approach it. Now, in thinking like that, we know that sine is opposite over hypotenuse. So I know that my opposite would be 7, and my hypotenuse would be 25. Now remember, if it's a triangle, the lengths can't be negative. However, it is common for kids to forget that. So I would actually put a negative 7 there just to help you remember, okay? So I'd have to use the Pythagorean theorem to find the missing side. Now, if you really watch that video on Pythagorean triples, you know that there is a 7, 24, 25 Pythagorean triple, okay? And that is important and very helpful. Okay, so here would be 24. Now again, I have to remember it's actually negative because it's a negative x in that quadrant. So I'm going to put a negative. Again, a triangle can't have negative values, but I'm doing that so I don't mess up. Okay, so I've got my sine theta equaling, I have everything I need to find the 6 trig values, 7 over 25. Cosine, well, cosine's going to be negative as well, and it's adjacent over hypotenuse, so it's going to be negative 24 over 25. Okay, tangent's going to be positive in that quadrant, right, because sine over cosine, and all students take calculus, so that would be 7 over 24. Okay, so then, for the other ones, cosecant is the reciprocal to sine, secant is the reciprocal to cosine, and cotangent is reciprocal to tangent. All I'm going to do is I'm going to flip them. So negative 25 over 7, negative 25 over 24. Ooh, my pen's a little slow today. And 24 over 7. Okay. Now, there is another way to do this. You can label this as your x and this as your radius. And remember that x squared plus y squared equals r squared to find y, and you don't have to draw it. I just tend to use the visual, and that's how I taught it in these videos, okay? All right, moving on to number 12. Ooh, this was a log review, because on every test in our math department, there is cumulative review, and logs are hard, and it really shows if you understand what logs are. So this says expand, well, it actually says rewrite the log in terms of a and b. All right, so rewrite the log. Well, this is an expression, so the only thing I can do with expressions that are logs is really simplify them. Simplify or condense. It's already condensed, so I could expand it. Because I want it written with 7 and 5 so I could replace or substitute a and b. And I kind of see that 7 times 5 gives me 35. All right, so what am I going to do first? Well, I might see that it's division, and I might recognize the property of logs that says if you have log base 2a over b, then you can rewrite that. You can expand it as log base 2 of a minus log base 2 of b. So I might use that property first. So let's do that. Log base 2 of root 35 minus log base 2 of 8. Well, that actually does help me because log base 2 of 8 I can evaluate. Remember, log base 2 of 8 just means 2 to what power gives you 8. So let's think about that. You could set it equal to x, use the fishhook or around the world, so 2 to the x equals 8, so x equals 3. So I know that this is going to be minus 3. But I still have to work with this log to root 35. I always tell students, don't ever use roots with logs. First, turn it into a rational exponent. So that would be 35 to the 1/2. Okay, so we have another property of logs that we have to remember here. That would be that if you have log base 2 of x to the 1/2, that power, 1/2, can be moved to the front of the log, giving me 1/2 log base 2 of x. Okay, so I'm going to do that. So that's going to give me 1/2 times the quantity log base 2 of 35 minus 3. Okay, so now I want to somehow expand log base 2 of 35 using 7 and 5, okay? All right, so I know that the last property that I can work with, here, let me make some room here, would be that if you have log base 2, I'm just using base 2, but I could use any base, a times b, that you could write it as log base 2 of a plus log base 2 of b. Those properties are really important for solving equations with logs. Okay, so I know that 35 is 7 times 5. I can rewrite that so I can use the, this property. So that's going to give me 1/2 log base 2 of 7 plus log base 2 of 5 minus 3. Okay, well, log base 2 of 7 we said was a. And log base 2 of 5 was b. And so there is my expression written in terms of a and b. Really love this problem because it actually uses the 3 major properties and also asks you to understand evaluation. Now I did put a hint, remember, log base 2 of 2 equals 1. Because with these types of problems, you can actually always use 1 because 1 times anything is 1. It's not really changing the value. So sometimes when you're writing these, you might need to use the log of that same base. In this case, we didn't have to do it. We could have, but we didn't have to. All right, one more log. Oh, exponential, sorry, exponential. So this is a question where you'd actually have to use logs. So this is an exponential equation, which means we have to solve it. So step 1, if it's exponentials, I always want to see if there's a way for me to make the bases the same. In 5 and 2, there's no way I can make a base 2 number with 5. Like 5 can't be turned into a base 2 number. So this tells me I have to use logs. So remember, the log function is an operation, right? It's a symbol. It is not a word. So to solve, you have to undo the exponent using the inverse operation, which is a log. So I'm going to take the log of both sides. Okay, now I'm going to use the power properties to help me. I'm going to bring the exponents to the front. So that's 2x minus 3 times log 5 equals 3x log 2. Now remember, we're solving for x, so we do have to figure out a way to isolate x. Now this can be challenging, right? The first thing that we have to do, and it says provide as an exact value, so get a calculator ready. So we can't put this in our calculator, or we're going to get an estimated answer. So this is where I gotta get those x's alone, and I have them in a parentheses here. So if I had given you, I don't know, 2x minus 3 times just 5, what would you do? Well, now hopefully you say you distribute. So now you're going to distribute the log, because remember, log 5 is a number. So I'm going to distribute. So that's going to give me 2x log 5 minus 3 log 5. Again, keep thinking, log's a number. I know it looks like a word. Okay, tricky now. Again, we want to isolate x. We want all the x's together. So that means I've got to get 3x log 2 to the other side. So I'm going to subtract. I'm going to subtract it. Oops, 3x. And I'm going to add 3 log 5 to the other side because that's a plain old number. There's no x in it. I'm going to isolate it to the other side. Okay. All right, so now this is a tricky part. I do have to get x alone, and I have to recognize that x is the common factor in this expression on the left. So I'm going to have to factor it out. All right. Last step would be then I want to get x alone. So how do I do that? Well, x is being multiplied to this entire product. And I know it looks funny, but I can divide it on both sides. And so that is my answer for x, is an exact value. Calculator ready. So I could put that in my calculator and get an estimated answer. All right. Sorry about that being a long video, guys. I hope you have a great day.